So I'm sure you've heard a lot about COVID-19 or coronavirus recently. COVID-19 is a disease that spreads through human-to-human contact. So when someone with the disease encounters someone without the disease, they can make that person sick. Now, while COVID-19 is a dangerous disease, there is always something to be learnt. In this case, COVID-19 can teach us about multiplication. To begin with, let's imagine that this blue circle represents someone that's healthy and well. When that circle turns red, that means that person has become sick or they've become infected with COVID-19. Now, let's call that person case 0. If that person isn't careful in practicing their social distancing, they could go on to easily infect 2 other people. Those 2 people could go on to infect 4 other people. Those 4 people can go on to infect 8 other people. Those 8 people go on to infect 16 people, and those 16 people go on to infect 32 people. And before you know it, the spread of the disease has gotten out of hand. Now, let's take a closer look at the numbers. To begin with, we start with 1 person. The next is that 1 person infects 2 people. Those 2 people infect 4 people. 4 infect 8 people. 8 infects 16. 16 becomes 32. 32 becomes 64. I'm sure you could recognize that what we're doing is we're doubling the numbers each time. Now, let's call the first level of our diagram here level 0. Next one's level 1, level 2, level 3, level 4, and then finally level 5. Let's begin at level 1. We can see that at level 1 we have 2 people that are infected. At level 2 we have 2 groups of 2, so we have 4 people infected, but a way we can write that using multiplication is 2 times 2. At level 3 we can see that we have 2 groups, and within those 2 groups we have 2 groups of 2. So using multiplication we can write that as 2 times 2 times 2. As we continue down the diagram at level 4, we can see that we have 4 lots of 2. And at level 5 we have 2 times 2 times 2 times 2 times 2, which is 5 lots of 2 multiplied together. Now, if we had to continually write out all these 2's, we'd quickly run out of ink and we'd quickly run out of paper as well, especially if we wanted to go to higher levels of the diagram. So there's something in maths called exponentiation. And what exponentiation allows us to do is to write these really big numbers in a short way. Take a look at this example down the bottom. 2 is what's known as the base, and the 1 that's written smaller to the upper right hand corner of the 2 is called the exponent. Now the exponent tells us how many times the base will be used in multiplication. Overall, this is known as the power. So we would read it as 2 to the power of 1. Now, this example belongs at level 1. And what it means is we use 2 in the multiplication process once. So we use the base once, which is given by the exponent. So 2 to the power of 1 equals 2. If we do the next level, the base is still 2. The exponent, because we're at level 2 now, is 2. And we have 2 times 2 equals 4. As we continue down, we have 2 as the base still. Now we're at level 3, so the exponent is 3. And this equals 8, because it's equivalent to 2 times 2 times 2. As we keep going, 2 to the power of 4 is 16. It's the same thing as 2 times 2 times 2 times 2. And lastly, at level 5, the exponent is 5, and we've multiplied 2 together. We've used 2 5 times when we multiplied it together, and that equals 32. Now, the last thing we have to consider is level 0. What's happening at level 0? Well, it seems to me as if there's only 1 person at this level. So that means our answer has to be equal to 1. Now, how can we write that with this new way of writing it that we've just learnt about, this new exponentiation way of writing? Well, we know that each time we're doubling the number, So, and we also know that the exponent we've been writing along the left-hand side here, the number at the top right of the base, has always been equal to the level that we're at. So at level 0, it would make sense that the exponent is equal to 0, and the base still remains to be 2. So we would write it as 2 to the power of 0 equals 1. In fact, any number that you raise to the power of 0 is going to be equal to 1. Now, let's have a quick look at what things might look like if each person only infected one other person. So the first person infects one person, that person infects one person, that person infects one other person, and so on down the diagram. We can see that when the level of infections decreases by methods such as social distancing, we go from everybody in this diagram being infected to just 6 people. We've just shown a real-life application of the mathematics that has informed our response to COVID-19 and shown that no matter how bad the situation, there is always something that we can learn.